To begin with, we will start with the analysis of the experiment itself. Okay, analysis of the experiment itself. So yesterday, whatever experiment we have conducted, I have taken a shot of that and I have put it on the screen. I hope all of you can see this.
Yes,
Huh? Yeah. Other students there on the online, you can see the screen. Hello?
Yes, sir.
Yes. So the first diagram, the first diagram that you see here. Okay. So I think it is quite evident. This becomes what? The incident ray. This is the slab. A, B, C, D. This is the glass slab that we have kept. The rectangular glass slab. So this is the incident ray, as you can see here. Okay. So this is the incident ray that you can see here, all of you, right? And what you see, this line is the normal at this surface. And you can see a thin line here. This is the reflected ray, right? That is part of the light that is getting reflected. We are not going to deal with that. Now here this ray would have traveled like this. Okay? So but because of refraction, it has deviated. Right? And what is this? This is the normal. So you can see that the ray would have traveled like this. Now instead of traveling like this, it has deviated. Okay, and this becomes the angle of transmission. I am using it as theta t. I am using a different notation. Theta I is for angle of incidence. Theta r is for angle of reflection. Theta t is angle of refraction. And here the ray is emerging. And once again, I am drawing a normal here, and this angle becomes theta e, the angle of emergence. I hope everything is clear. Right. And we measured all these angles, theta I, theta r, theta t, yesterday, and we have noted these values. So theta I is 17 degrees, theta r, no, it is not theta r, it should be theta e. Correct? Yesterday I was using that symbol. So it should be theta e, theta e. Right? It should also be theta t. Right? Theta. So it should be theta t. Right? We have got this series. And we slightly altered it, we turned it, and therefore we saw for a different angle of incidence. That is, now here the angle of incidence is 17. We got the corresponding angle of transmission as 10. Here the angle of incidence is 26. We got the corresponding angle of transmission as 15 degrees. This was our experimental observations. I have presented these observations on the board for all. Okay? Right. Now, any questions in this, please ask before I proceed to the next page. So, you are convinced that the refraction is a phenomena wherein light traveling in a medium, in this case it is air, and it enters the surface of another medium. In this case it is glass. Glass is more optically denser than air, and therefore the ray of light will bend towards the glass. The ray of light will bend towards the glass. Okay, towards the normal. The ray of light will bend towards the normal. Okay. Again, the same ray of light is traveling through the glass, and then it will travel back to the air. So here it is going from optically denser medium to optically rarer medium, and therefore this ray would have traveled like this. This ray would have traveled like this, but for the glass and air fraction, and therefore it is moving away from the normal. Because well, yesterday we used the concept. This air is called rarer medium. Glass is called denser medium. Optically rarer medium, optically denser. Right? I hope you have seen this phenomenon. And then what we saw was that the incident ray and the emergent rays, they are parallel to one another. Why? Because the angle of emergence is equal to angle of incidence. And then we also noticed, come to this diagram,
Sir, what is that? Like incident ray.
Get up and your question.
So the incident ray inside the glass slab. Is it equal to the emergent ray or it is different?
Which I have written you theta, I, theta, and all. Which angle are you asking?
So there is no angle.
You ask the which angle?
No sir, that angle is not mentioned. So there.
Which diagram? Diagram 1 or
diagram 2? Diagram 1.
In diagram 1, which angle?
That incident ray in the glass slab.
Incident ray in the glass slab. Incident ray in the glass slab. You are asking which angle? This angle. See, this angle is theta t.
No sir, that side of that angle.
This angle.
Yes sir. That is equal to which angle?
This is equal. See, now this parallel, this normal is parallel to this normal. Correct? And this line is a straight line.
Yes, sir.
So these two angles are alternate angles. So therefore, this angle will be equal to this angle. Okay? And yesterday we have discussed this. If you remember. Anyways, yes. So your one thing that you have asked is very correct. So now this angle becomes the angle of incidence for this refraction. So again it is refracting here.
Yes,
Because it is going from this medium to this medium. Correct? Clear now? Okay? Right.
Yes, sir.
Thank you, Srinath. I think Sanidhi and Aditya also should keep telling yes, sir, once in a while.
Yes, sir.
Yeah, then
Yes.
I will feel nice that you are also learning. Great. Wonderful. So I hope you got it. Any other doubt? Now, Fardeen's question is about the lateral shift. We'll come to this later. So now you see this incident ray, and this is the incident ray and this is the emergent ray. I hope you can see this, right? Hello?
Yes.
Now you see this emergent ray is parallel to this incident ray. I hope you can notice that.
Yes.
Yes, it has refracted here. It has refracted here. And then see, it has refracted here and then come out like this. It has refracted like this and come out here. But whatever ray has come out here, this is parallel to the original incident. And that means now yesterday I explained, without the glass you should keep your eye here. And then when you place the glass, okay, to see the same ray. Yesterday you remember we conducted the experiment, we kept 2 pins here.
Yes.
And from here if you see in such a manner that you see only 1 pin.
So
Hello?
Pin 1, pin 1, say tell the example.
Yeah, I will tell you. See, yesterday I had kept 2 pins here. 2 pins here. I had put 2 pins. That is a glass slab. I had kept it on a thermocol sheet and I had put 2 pins. And then I saw these pins from here. I kept my eyes like this. How many pins did I see? 1 pin. Okay. Then I kept the glass slab. Hello.
Yes.
So my eyes was still here. Now think and tell. Before no glass slab, my eyes was seeing only 1 pin. Now I kept the glass slab. Right? After keeping the glass slab, how many pins will I see?
2 pins.
Louder!
2 pins.
Louder!
2 or 3.
Loud!
2 or 3. 2.
Now see students, their rays must, from the pins must enter your eyes. I am only using 1 ray and it should enter your eyes. So your eye was here and without the glass slab you are seeing only 1 pin. Correct? Now when you place the glass slab, the ray from this pin is not traveling in this direction. Hello?
Yes, sir.
Yes, sir.
So,
Yes, sir.
so what will you see here? Sunny's and Aditi's and Srinath's and everybody here can answer. So now if I keep the glass slab, how many pins will you see?
One,
Zero,
sir.
sir.
Pardon?
None, sir.
1 pin, sir.
1 pin. You tell.
We can't see. Because the light
Neha is telling she cannot see any pin. Anybody else?
Yes, sir, we cannot see.
So I can't see anything. No pin.
Good. So you can't see any pin because, see, now I am able to see this object because the light is entering here and entering my eyes. You got it? Then only I am able to see this object. Right? See, after reflection from the object must enter your eyes. Then only you can see that. So now here, if you are keeping your eye here and keeping the glass slab, the ray from this after reflection cannot enter your eyes at all. Hello, are you with me?
Yes,
sir.
Now, what should I do to see
We
the
have to
pin?
take the eye on the
So I should
now
now good Neha. So I should move my eyes slowly. So I will move my eyes from this point to this point. I'll move my eyes. Now you see the rays from this are traveling like this and it will enter my eyes. Now I am able to see one pin again. I am able to see one pin. Got it?
Yes.
So here you see, to see the same object on the other side of the glass, I have to move my eyes by few centimeters. Got it?
Yes, sir.
I have to move my eyes by few centimeters. So how much I have moved my eyes? That is the lateral shift. Are you convinced or not convinced?
Yes.
Hello, everybody there?
Yes, sir.
Yes, sir.
100%
Yes, sir.
because you are going to solve wonderful problems based on this. Okay? Wonderful problems based on this. That is why I am asking you again and again. Now, what point you didn't understand here, you should ask.
Then, if we shift our eye to like where the rays come from, sir.
Huh.
But the object is placed like this and our eye is like this, so we can see the two pins at that time.
That is what is the phenomena here. See, you try to understand. You will see the any object provided the ray from that is entering. See, now the ray is on this object and it is entering my eyes. Now what is happening? This ray is coming like this, it is deviating like this, and it is coming like this. So I have to move my eyes now.
Yes.
See, now, see, my eyes should follow. So this is glass slab. I have just not glass slab, I have just drawn a line. ABCD is just a line. So there is an object. Okay. So light is falling on this object. So what happens? Light falls on this object and then starts getting reflected. Hello.
Yes, sir.
So assume that light is falling on this object and it is getting reflected. Okay. Now if you keep your eyes here, you are able to see this object. Oh, correct?
Yes, sir.
Correct?
Yes,
Now you see, if you now keep a glass slab here, what will happen?
The light here.
Hello, tell me what happens.
The light gets
So
reflected.
now you see, you draw it normally. So this ray of light now, will refract. Then it will come out. Hello, are you with me?
Yes, sir.
Yes, sir.
Again here there is a normal.
Yes, sir.
Again here what happens? Again this one, see, it should have gone straight, but it will bend away from the normal. Hello.
Yes, sir.
Okay, and it will come out like this, sorry, straight like this. See, this line and this line are parallel.
Yes.
Now the ray from this was originally coming here, so you had kept your eyes here. Now, if you are keeping your eyes here, you will not see any ray coming. Hello, it is no ray is entering. Hello, understood now?
Yes, sir.
Because if
Yes, sir.
Yes, sir.
if you keep the glass slab, okay, if you keep the glass slab, this ray will disappear. If you keep the glass slab, this ray will disappear.
Yes, sir.
Are you with me?
Yes, sir.
Yes, sir.
Okay. So originally you had kept your eyes here. Now since you kept the glass slab, that ray itself has disappeared. So now you have to move your eyes from here to here. Then only you will see. So how much your eyes has moved? That is the lateral shift. Hello, are you with me?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Still if you have doubt, you ask. I will explain.
So if we take it in the format of in the form of phrase, it means that the shift of the incident rate is known as latitude.
Here, did the incident ray shift?
No, means
Listen, did the incident ray shift here?
No.
Incident ray is same.
Yes.
What has shifted?
The eye.
Why did it shift?
Because it was not getting the rays at it.
Correct.
And it was
Now,
not
then
so.
what did you shift to see the object here? What did you see? What did you shift to see the object? You shifted your eyes, no man.
Yes.
You shifted your eyes. Why did you shift your eyes? Because the ray from this was coming in this direction after refraction. Okay. Now, supposing this glass was not there. Supposing this glass was not there. Okay. Then this ray would have travelled straight like this to your eyes. Now, the moment you introduce the glass, okay, the moment you introduce the glass, this ray now is going to travel like this and like this. So there is a shift. See, this ray which is coming out has shifted from here to here. That is lateral shift. Again, ask the question. You have a doubt. No, if you have, you ask. Don't worry. See, I am not the best teacher in the world. So it is not that I have convinced you and you are getting convinced. I am not a great teacher. So there can be a lacuna in my teaching. So which I have not convinced you. So you are free to tell me that, sir, I didn't understand. I will give you another example or something like that. Wait, I am talking to you.
Sir,
Understood?
Yes.
Lateral shift.
Yes.
Everybody?
Yes.
Okay. Last lab ಇಟ್ಟುವುದರಿಂದ the emergent ray. ನೀ ಆಗಲೇ ಏನು ತಪ್ಪು ಯೂಸ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ you use the word incident ray. You should have told emergent ray. That is the mistake you did. I felt so, but still I wanted that to be heard from you. So this emergent ray shifted its position from here to here. Right? Emergent ray shifted its position, not the incident. Incident. See, we are conducting an experiment with certain conditions. So we have already drawn the incident, and then with that we are doing. Okay? Any question? Ask now.
Yes, sir. The
Louder.
lateral shift means the shift of the emergent ray, no, sir?
Yes.
So I should mention that I should mention, or directly you can write if they ask a definition, then you can write this.
No, wait. You ask the question very clearly. Very clearly.
Yeah,
ask.
like
You don't change the condition and all. What is your question? You coin proper.
Like definition of the lateral shift.
You tell, sir, please define lateral shift. Simple, no, put it simple. Sir, please define lateral shift. Correct? Yeah. See now, you understood what is this lateral shift that has happened place. Okay? So here you see, when there is the object is being seen, because the light is falling on the object and reflected and entering your eyes. Okay? So when we keep a piece of glass or some different optical medium in between the object and your eyesight, when you keep another optical medium between your object and eyesight, when you keep you understand, when you have kept a optical medium, then the emergent ray will shift its position along the edge of the optical medium, as you have seen here. This emergent ray shifted its position. Okay? So the amount of shift is called the lateral shift. Okay? The amount of shift is called the lateral shift. Clear? Remember, this line I am drawing here is perpendicular to this. So there are two parallel lines now. One is the original emergent ray and now the new emergent ray. The distance between them is called the lateral shift. Clear? Any other doubt? Hello?
No, sir.
This is one phenomenon. Okay, that's right. So now, hello friends, good morning.
Good morning, sir.
Okay, quickly I am just demonstrating an experiment. You can see on the board here that you have got a laser beam, okay, on that spot, and now what I have in my hand is a piece of rectangular glass. Okay, so I am going to place it in front of the laser, and you have to tell me what you observe.
Yes.
Okay? Well, I have placed it in front of the laser. Now I placed it in front of the laser. Okay, what did you observe?
It's shifting its position.
Louder!
Shifted
It is shifting its position to the left. Okay, it is shifting its position to the left. This is called lateral shift. See, now the ray is directly coming from the source to this point. Okay, now if I insert a glass slab in between, the ray will shift to the left. So this is called lateral shift. Okay, now this will depend on various factors. You will have the derivation in your PUC too. All I can tell you is, well, I am switching off the laser. Right? So all I can tell you is that the lateral shift will depend upon the thickness of the slab. Right? Supposing I was keeping it like this. So this becomes the thickness of the slab. It depends upon the refractive index of the slab. Okay? And it will also depend upon the angle of incidence. Angle of incidence, thickness of the slab, and the refractive index of the glass. So the lateral shift. Right? It's all going to depend upon this. Yes, Mr. Lake, what you need to do. So you define one normal. Okay, this is the normal to the slab. Then you define a ray of light like this. Now this ray of light will have traveled like this. Okay? Now because of the glass slab, it will bend towards the normal. It will bend towards the normal. And again here you define one more normal. Okay? Now you define one more normal. Now but for the slab, this ray would have traveled like this. Okay? Now what happens to this ray? It will bend away from the normal. Okay. So this will bend away from the normal, and this is parallel to this. This is parallel to this. Okay. So this happens. Now you see, this is the original ray. We don't have traveled like this. Now I am going to have a screen. This is the screen. So what you saw here was the light ray would have it here. Now it is here. Understood? Now it is here. Okay? Hello. Now what is the lateral shift? Lateral shift is, now understand this. The screen what I have put here, I am supposed to put the screen perpendicular to this board. Perpendicular to the ray of light.
Yes.
Okay. Now this becomes the lateral shift. This line, what I have put is the lateral shift. Okay? That's precisely what you observe. Of light has shifted its position laterally. See, it has shifted its position laterally, means along the sides. This is the lateral shift. Okay? I have drawn the normal here, one normal here, one normal here. Okay? Now what I meant to say there was that. Okay? So now you see the emergent, for emergent ray I have drawn a normal here. For the refracted ray, I have drawn the normal. Okay, for the emergent ray here, and for the ray which should have traveled straight, I have drawn. So you can see that you have to draw two normals. So something like that. I think I am wrong. Maybe slip of tongue, because when I am speaking too much, maybe that one slip, and that you have captured. Okay. See, now had the ray of light gone straight, perpendicular, then the normal is also here like this. So this ray of light would have traveled straight only without any shift. So if you increase the angle of incidence, then the lateral shift will also be. Okay? See, it's the consequence of the bending of light. Bending of light, refraction is a phenomenon. Reflection is a phenomenon. Right? So lateral shift is a consequence of that. And that depends upon the arrangement. Please understand. So what I told you, now if I define lateral shift SL, so SL now is a function of the refractive index. The refractive index of the material and the thickness of the material. Okay, and the angle of incidence. this angle of incidence. It depends upon all this. How much it shifts. Like this. And so here it's very clear. If the angle of incidence is 0, then the lateral shift is also 0. You will get that relation. Okay? Anything else? If you have confusion, yes, good. That confusion is good that you got it clarified. Everybody else have got everything? Fine. So